Okay, so we're going to look at finding the X and Y intercepts of a quadratic. So remember, quadratics have a power of 2 and their graphs make parabolas. The first thing we have to discuss is when we find the X and Y intercepts. Let's start with the Y intercepts. How many are there going to be? That's what we want to talk about. On the picture I just drew, it looks like there's only one right there where it hits. Is that always going to be the case? Think about if I move this parabola left or right. Is it going to hit more than once? What if I flip it upside down? What if I make it, if I shrink it and make it skinnier? What if I vertically stretch it and make it skinnier? What if I vertically compress it and make it wider? It's still always going to only hit once. One of the questions is, well, what if it's like over here? But remember, parabolas just kind of keep getting wider and wider and wider and wider. They just get wide slowly over time. They go up a lot faster than they go wide. So eventually it will hit the y-axis somewhere up here. Okay? So there's always going to be one y-intercept. Another reason why you can't have two is because if it had two, it wouldn't be a function. Because if it had two, I would have to kind of have it hit once here and then like fold back on itself and hit again or something. And now we've got the vertical line test is not passed, right? It's not a function. These are functions, these parabolas. So there's only going to be one y-intercept. Okay, one y-intercept at all times. Exactly one, not less and not more. So how do we find it? Y-intercepts, where are they located? Well, if I draw my graph here, this parabola hits the axis, the y-axis there. The coordinates at that point are 0 something. I don't know exactly what they are. That's the point. I want to find the y. But I know the x is 0. It has to be. To get to any point anywhere on the y-axis, the x coordinate has to be 0. So if I shifted this parabola, say, up with a translation all the way up here. So this is a different parabola now. I've just shifted it upwards. Notice what happens. The y-intercept just shifts upwards. But the coordinates at that point are still 0. It's just, we have to find what's the y. So that's the question. We want to find what the y is. So when I ask you to find the y-intercept, you're really just trying to solve for y. So let's look at an example. Find the y-intercept of y equals 2 times x minus 3 squared plus 4. So we know that this is a parabola. Let's get a sketch of it first. I start at 0, 0 with my vertex. It's now shifted right 3 and up 4. That's what the negative 3 and the plus 4 do. And then the 2 makes it a little skinnier. So I know it looks something like this. So where's it going to hit the y-axis? It's going to get wider slowly. It's going to hit the y-axis somewhere really high up on the y-axis. Let's find that number. So if we know it's going to hit, if I extend this y-axis up, I'm going to guess it's going to hit, let's say, somewhere up here. I know that that has an x-coordinate of 0, but I don't know the y-coordinate. So the way you find the y-coordinate is you go back to your equation. You know x is 0, so you plug in 0 for x, and you solve for y. So we get y equals 2 times negative 3 squared plus 4. Negative 3 squared is 9, so we do that first. And then we multiply by the 2. And then we can add the 4. So y equals 22. That is not how you write your answer. A y-intercept is a point. We know it has a 0 for an x. Now it's got 22 for a y-coordinate. That's my y-intercept. And like I guessed, it's pretty high up on the y-axis. Okay, now let's look at, that was example 1. Let's look at how to find x-intercepts. So the question first is, how many x-intercepts does a parabola have? So we'll look at that same parabola we just drew. Right 3 up 4, and it's skinnier. This parabola has no x-intercept, so it's possible to have no x-intercepts. How about if so we know that that equation was y equals 2 times x minus 3 squared plus 4. How about if I took this one and I reflected it? If I reflected it over the x-axis, now how many x-intercepts does it have? This one's negative 2 x minus 3 squared plus 4. This will have x-intercepts in 2 spots, here and here. So it's possible to have 2 x-intercepts. Let's look at how to find these in each case, what happens. So we're going to do example 2. Find the x-intercepts of y equals 2 times x minus 3 squared, the quantity x minus 3 squared, plus 4. Let's do the negative one first, the one that actually has 2 answers. Y equals negative 2. We're going to reflect that so we get some answers. Well, just like before, x-intercepts, we don't know what the x-coordinate is for either one of those. That's what we're trying to find. But we know the y-coordinate on both of them has to be 0. If it's on the x-axis, the y has to be 0. So we plug in 0 for y, and we solve for x. So in solving for x in vertex form here, we're going to consider this like a chunk. So we want to solve for that chunk. That means we're going to subtract 4 off both sides to start, to get that chunk by itself. So I get negative 4 equals negative 2 times x minus 3 squared. Now, this chunk, I want to get it by itself, so it's times negative 2. So I will divide by negative 2 on both sides. And I get 2 equals x minus 3 squared. Now that I've got the chunk solved, I want to square root both sides. That's how I get rid of the squared. Now here's the part where 2 answers are created, because we know that this thing has 2 x-intercepts for the same y value. When you take the square root of 2, you get 2 answers. You get the positive answer, and you also get the negative answer. So when I square root 2, I get positive 2. We don't really show the plus sign. And on the other side, I get x minus 3, because the square root of squared cancels. All right, so here's where my equation solving, let me do this. My equation solving splits into 2 cases, because when I square root, I have the positive and the negative version. So now if I add 3 to both sides to solve, I'll solve the left side, the left equation first. I get the square root of 2 plus 3 equals x. There's one of our x-intercepts. And the other one is x equals, if I add 3 to both sides, I'm going to get negative root 2 plus 3. That's my other x-intercept. These aren't the answers, because x-intercepts are points. So I have to say the points are, for this point, it's 3 plus the square root of 2. That's the x-coordinate. The y-coordinate we know is 0. And 3 minus root 2. The x-coordinate is 0. Those are our x-intercepts. We can write these. We usually write the number without the square root first, so we can switch those around if we keep the signs. So that's why we get 2. It's this step right here when we square root. Okay? Let's look at the case when we get none. Let's see what happens. So we'll consider our parabola 2 times the quantity x minus 3 squared plus 4. That's this parabola. I'm not going to make it exactly accurate, meaning I just shifted it right and up. and it opens upwards, so it's going to have no x-intercepts. So when we plug in 0 for y to try to locate where it crosses the x-axis, let's look at what happens. So again, I want to solve for this chunk, so I'm going to subtract 4 off both sides. So I get negative 4 on the left side, 2 times x minus 3 squared on the right side. Now I want to divide by 2. So I get negative 2 equals the quantity x minus 3 squared. Now here's the step where it usually splits into two answers. When I square root both sides to get rid of the squared, you run into a problem. This is a problem. You cannot square root a negative number. There are no solutions to this equation. Therefore, there are no x-intercepts.